Another day, another story. In our previous lesson, we explored how the sine function is graphed using the unit circle. Today, we'll delve into the transformations of this sine function. The given function is y equals -3 sine 2x plus pi plus 1. The parent function is y equals sine x, as we depicted it in our previous lesson. As you all recall, it looked like this. Do you remember? Let's dissect how this function transformed step by step. Step 1. Reflection across the x-axis. The original function was -y equals sine x, so we need to understand that y has changed to -y. This corresponds to a reflection across the x-axis. Step 2. Vertical dilation by a factor of 3. For the same x values, the y values have tripled. Typically, we refer to this as a vertical stretch. As you can see, the amplitude has become 3 times larger. Step 3. Horizontal dilation by a factor of 1/2. For the same y values, the x values have become half as large. This is commonly called a horizontal compression, and it results in the period being halved. Step 4. Horizontal translation pi over 2 units to the left. If we factor out 2 from x, it becomes x plus pi over 2. Pay close attention to the factoring and the sign change. This represents a leftward shift by pi 2 units. Step 5. Lastly, a vertical translation 1 unit up. The entire graph shifts upward by 1 unit. By observing these 5 steps in sequence, we can clearly understand the differences. We can make a table for the steps of transformation. Now, if we plot the parent function and the final graph on the same coordinate plane, we can see the distinction more clearly. To grasp function transformations, it's essential to be familiar with the basic formulas and, most importantly, to pay close attention to the signs. See you next time.